So welcome to the second part of our discussion. We are still in division of algebraic expressions, and this time, um, like I said earlier, the second part will be the division of algebraic expressions using factoring method. So let's get into it. So a few weeks ago, I uploaded this review discussion about the factoring method, and I hope you can still remember the process on how are you going to factor or what are the techniques for you to determine if the given expression is factorable or not, or can be factored or it cannot be factored. Okay, so for this, by using factoring, let's begin with division of division. Okay, division of binomials. You may say trinomials and multinomials. If we still have time, multinomials by monomial. So this means that our for this division of binomials, trinomials, and multinomials by monomials, um, this means that our dividend could be binomial, trinomial, or multinomial, and our divisor is always the monomial under this part of the division using factoring method. For example, you have for example, number one, you have divide the quantity of 2x squared by 2x squared minus 4x by 2x, which means this is our dividend and this is our divisor. So for this example, our dividend is binomial. Okay, what we're going to do is just simply uh, rewrite this one into vertical in this form. You have 2x squared minus 4x over 2x. Okay. So when you say by factoring, so you have to figure out if there are terms or common expression that can be factored out from the first term of the dividend where that common factor is also common in the second term. And that is the time that you are going to apply the factoring, and that is what we call the common monomial factoring. For example, let's examine the first term and the second term. For the first term here, you have 2 as coefficient, and second term, you have 4 as coefficient. So that means between 2 and 4, there is a common factor of this coefficient, and that is 2. The greatest common factor between 2 and 4, that is 2. And for the variable here, there is also the same variable for the second term. And since x here is also common in the second term, that means you need to factor out x also. And when you do this, you have to factor the variable that has smaller exponent. So in this case, the first variable has 2 as exponent, and the second, the x has a smaller exponent. So this is the variable, this is the part of the variable where you need to factor out. So that means you need to factor out x from x squared and x. So that is x as part of the factor. So when you factor out 2x from the first and second term, for the first term, since you factor out 2, then the result is there is no more coefficient here. what remains is the only variable x. And then copy minus. Since you factor out 2 from 4, so the remaining value here is only 2. And then since you factor out x from this term, so there is no more variable here. So how are you going to check if that is the correct answer? So just simply try to do this one. X minus 2 times 2x. Can you still remember the multiplication of algebraic expressions? That is why you need the foundation on how to add, multiply, and subtract algebraic expressions. Can you still recall? So we multiply 2x to x, that is bring down 2, and then bring down x, and other exponent that is 2x squared. Then multiply 2x to 2, so that is 2 times 2 is 4, and bring down x because there is no variable here. And positive times minus, or technically positive times negative, that is minus. So that's it. If you know how to multiply also. And the only way for you to check if these factors are correct, the required factors of these original given expressions, is to multiply them back. If you will get the original given, so that means these factors are the correct factors of this expression. Then after that, just copy the denominator, which is 2x. So since now between 2x and parentheses there is no plus or minus, that means the operation between here and here is multiplication, because factoring is a process of breaking the expressions into two, at least two, in a form of product or multiplication. And we have also 2x here. So in this case, you can now cancel, apply the cancellation method, cancel 2x and 2x here. So it is just like 2x divided by 2x. So that is equal to 1. And 1 times x minus 2, so the result is x minus 2. So this is your answer. That is why I told you a few weeks ago that you need to master the idea of factoring, because you can use that one in our future discussion. And I give you long enough time for you to study and study and study. So therefore, that's 2x squared minus 4x over, or divided by 2x. The answer is, okay, x minus 2. And you can also, if ever it will be complicated for you to apply the factoring method, although the process here is factoring, you can do this process as your alternative way of performing this division. So the alternative is that for the 2x squared minus 4x over 2x, if you cannot apply the factoring method, you can also do this one. Just simply break this one, break the numerators into two fractions. Just like when you say for 2x, or just simply distribute 2x as the denominator of 2x squared and denominator of 4x squared. Break this one into two fractions. Why is it 2? Because we are basing the idea that the dividend or the numerator is binomial. So that means you can break this given into two fractions, like this is the result, that is 2x squared over 2x, and then apply the idea of subtraction of fraction, where when subtracting fractions of the same denominator, similar fractions, so just copy the common denominator and subtract only the numerators, and this will be 4x over 2x. So the idea of subtraction of numbers or fractions is being applied here. Okay, backward application. That means from this one, we are breaking this into two fractions. Why is it 2 again? Because it depends on how many terms are there in the numerator as our dividend. So since there are two terms, that means this whole expression can be specifically um, expand into two fractions, or you can rewrite that one into the difference of two fractions. Again, why is it difference? Also because the operation is minus here. So rule is when we subtract similar terms, meaning when we subtract fractions where denominators are the same, just copy the common denominators, that is the result, and then subtract only numerators, that is the result. And we can apply the idea to divide algebraic expressions if it will be difficult for you to use the factoring method. So, and then use the idea earlier for the part 1 of our division that if we divide the same numerator and denominator, just cancel it out. And then, since we are dividing the same variables here, using the scenario for number 2 in our quotient of powers, so that becomes x raised to the power of 2 minus 1. There is 1 here as numerator. I'm just trying to be detailed here. And then, so there is no more denominator. And then minus 4. Okay, 4. You can divide 4 by 2, so that is 2. And then you can cancel x, that is times 1. You can also disregard 1 since there is 2. And then x raised to the power of 2 minus 1, that is x, and that is minus 2. So you can also do this one. Either you will use the factoring or this alternative that is acceptable, or no, what we are presenting here is division of algebraic expression by factoring method. Okay, so this is just an example on how are you going to factor out if it is binomial, trinomial, division of binomial, trinomial, multinomial by monomials. Okay, so another one example under this. Supposedly for the second example, you have negative 4x cubed minus, shall we say, 6x squared, and you have plus, for example, you have 10x raised to the power of 5, for example, and then divided by, so we say, divided by negative 2x squared. So what is the answer? So the quantity of negative 4x cubed minus 6x squared plus 10x raised to the power of 5 divided by the quantity of negative 2x squared. So just simply, if you can apply factoring, then do it. So for the factoring, just rewrite negative 4x cubed and then minus 6x squared plus 10x raised to the power of 5, and then all over negative 2x squared. And then after that, try to factor out the common monomial from these three terms of the given. So beginning with the number. So that is 4, 6, and okay, 4, 6, and 10. So in this case, between 4, 6, and 10 as coefficients, the common here, the greatest common factor here is 2. So you may write here so that you can be guided. The greatest common factor is 2 for the numerical coefficients. And if possible also, if the numerator, if the divisor is negative here, you may also include negative here. That is just one negative 2 as the factor here. However, if you choose that the common factor is positive 2, that is still correct. As long as the suggestion here is just be careful with the signs if you are dealing with the signs, especially when you are factoring. Okay, supposedly, we choose that the factor here is positive 2, the common factor of 4, 6, and 10. Then after that, factor out also the common variable. Since variable x is common to first term, second, and third, that means you can also factor out x. Again, choose which one has least or smallest exponent. So since the smallest exponent is 2, therefore factor out x squared. Factor x squared out, okay, from the entire expression. That means the common monomial factor is 2x cubed. So that is your factor, common monomial factor. Okay, 2x squared as your common monomial factor. And then, okay, so by factoring 2x squared, from the first term, so what remains here in the first term is just for negative 4, the remaining coefficient is negative 2. And then since you factored out x squared, the remaining exponent for the variable here is only 1, so that when you multiply x squared and x, the result is x cubed. And then when you factor out, okay, when you factor out 2 out of 6, the remaining value here as coefficient is 3. And just copy the operation. Since you factor out x squared from this expression, so there is no more variable and exponent here for the second term. Only 3 as the constant. And when you factor out 2 from 10, okay, just bring down plus, and then when you factor out 2 from 10, the coefficient here becomes 5, so that when you multiply 2 times 5, that becomes 10. And factoring out x squared from x 5, okay, x to the power of 5, okay, the remaining variable here and exponent is x cubed, so that when you multiply x squared times x to the power of 3, the result, copy the common variable and then add their exponent, that is 5. So therefore, when you factor out 2x squared from this one, okay, when you factor out the common monomial, 2x squared from this expression, the resulting second expression is negative 2x minus 3 plus 5x squared. And bring down negative 2x squared. So you can now divide 2x squared and negative 2x squared. So by dividing this one, okay, the result is 1. However, since this is positive and negative, you may show your negative 1 as the result, because negative positive divided by negative is negative times the entire expression, negative 2x minus 3 and then plus 5x. So that's it. And when you multiply that one, because you need to be careful with the negative, so distribute negative 1 to each term inside the parentheses. So negative 1 times here, negative times negative is positive, and 1 times 2x, that is 2x. And negative 1 times 3, that is 3, and then multiplying negative and minus, that becomes plus when you multiply the same side. And multiplying negative 1 to the third term, that's 5, 1 times 5, that is 5. And negative times plus, that is automatic minus, and then bring down x cubed. So therefore your answer is 2x plus 3 minus 5x when you divide negative 4x cubed minus 6x squared plus 10 x raised to the power of 5 by negative 2x squared. Or you may rearrange the result beginning with the negative 5x, it becomes negative because it is minus here, and then followed by positive 2x, so 2x becomes plus because it is positive, and the last one will be the constant without variable here. Okay, so it is ideal that for the final answer you have to rearrange, you have to rewrite the resulting expression in descending order, that is from highest exponent down to the lowest exponent. And again, if you believe that it is complicated for you to factor out common monomial, you can also apply this one here. For example, you have for that one, for that part, okay, that is, you just have to rewrite, uh, negative 4x cubed and then minus 6x squared and then plus 10x raised to the power of 5 over negative 2x squared. And like what we did here for the alternative, you break this one into three fractions. There are three fractions now because the dividend has the term. So that becomes negative 4x cubed over negative 2x squared. Okay, so negative 2x squared. And the operation is minus. That is 6x squared over negative 2x squared. And then plus 10x raised to the power of 5 all over negative 2x raised to the power of 2 here. You can also do this process. Then cancel the common numerator and denominator one by one, term after term. And I would suggest if there are complicated signs or multiple signs, I suggest to do first for the signs. So you have negative divided by negative, that is positive. So your answer here must be positive. And 4 divided by 2, that is 2. And then you are now dividing the same variables where exponents in numerator is the same, bigger than the exponent of the denominator. So the variable and exponent in denominator will be eliminated. So copy the variable in numerator because it has bigger exponent, and that becomes 3 minus 2, that is 1 or simply 1. And then the same here. For this minus and negative, you can still apply the division process or just simply multiply this one and dividing two distinct signs again or multiplying two distinct signs, so that becomes plus here. And 6 divided by 2, that is 3 automatic. Do not copy negative anymore because you are simplifying already the signs here. That becomes plus. And then cancel when you divide the same variables and exponent. That becomes 1. Then 1 times 3, that is 3. And then again for the operation, so that is, it is just like opposite signs here. So that becomes minus and then or negative, and then use that one as minus. And that becomes 10 divided by 10 divided by 2, that is 5. And you are dividing the same variables where the exponent here is bigger than the exponent of the denominator. So that becomes, copy x in numerator and subtract 2 from the exponent of numerator, that is 5 minus 2, that is 3. So this is automatic your answer. Or you may rewrite that one into negative 5x cubed plus 2x and then plus 3 as your final answer. Okay, so that's it. That's how you apply the factoring method when we divide binomials, trinomials, multinomials by monomial as our divisor. And for multinomial, you can still do the same. Just try to examine or look for the common monomials and factor that out from the given expressions and then proceed to division. Or you can use this alternative way, breaking the expressions into more than one fractions. Okay, so after this division of binomial, trinomial, and binomials, let's proceed to still in division of algebraic expressions by factoring, but this time our divisor could be a binomial or could be a trinomial. And this will be the last part for this division by factoring. Okay, so we will take a short break and then after this one we will continue. So stay tuned and don't leave because in a short while we will proceed to the division by factoring where our divisor is binomial or trinomial. Thank you.